All right, so we're looking at slope finally. Slope, we're going to look at 3 different ways. We're going to look at it from a graph first, and I'm going to show you how to find it from a table. And then the old school way, find it from 2 points using a formula. Okay, now I highly encourage, don't memorize the formula. If you understand the concept by the end of today, try to use the other methods. All right, so when we're looking at a graph, we're going to find slope. It's going to be a ratio of our vertical change over the horizontal change. So what you want to look for is a better ratio is rise over run. Rise over run. So let's add this into this description down here. A lot of you have heard rise over run before. Okay, the rise is referring to the change in your y value, a vertical change. So we'll call that rise. And then the change from left to right, we'll always run to the right though. We'll call that run. All right, let's go back to our graph up top. So we're looking at this graph. The first thing we have to do is find the vertical change between A and B. So we want to find the vertical change between A and B. We're looking at how it goes up or down from a point. These are all listed here as A, B, and C. Okay, they chose these because they're in the corners of a square on the grid. If you look closely, all these points are in the corner of a square on the grid. They represent whole numbers. Okay, so we look at from A to B, we're going up 1, 2, 3 spots. So it's a vertical change of up 3. So a positive 3 there. From A to C is a bigger jump. We're not going up 3, we're actually going farther. We're going up how far?
4, 5.
1, 2, 3, 4, 5, 6 it looks like. To be level with C, we'll have to go up 6 there. That'd be 6, a rise of 6. From C to D, 1, 2, 3, up 3. All right, let's find the horizontal change now, how it's changing left to right. Okay, now we're looking at going back to A and B. Okay, from A to B, you have to go left or right. You have to go to the right, how far?
4.
4. 1, whoops. 1, 2, 3, 4. To the right, 4. To the right, 4. So positive 4. Okay, when we run to the right, it will always be positive. Okay, and we're going to learn we want to read the graphs left to right. So our run will always be a positive number on the bottom here in a second. All right, let's do the next run. From A all the way to C. All the way to C. The C value, or the X value here for C is 4. So how do you get from negative 4 all the way to positive 4? You have to go up 8, all right, to the right 8. To the right 8. So a positive 8 there. All right, what's the last horizontal change from C to D? It's 4. 1, 2, 3, 4. To get level with D. So 4. All right, now we're going to build these as ratios. The vertical change, all the green numbers, over all the red numbers, the horizontal change. So let's go ahead and move down to number 4 here. So when we build these slopes, these ratios, we're putting the change of y on top. So that first change was 3. It was up 3 and then over to the right 4. So 3/4 is the ratio for the slope. We do the next one. We went up 6 and then to the right 8. That can reduce to what? 3/4. 3/4. So remember, always reduce your ratios. And the last ratio is going to be what? Up 3 and to the right 4. So what do we know about all of these? They're all the same. They're all 3/4. Even if we got a number like 6/8, it reduces to be the same slope ratio. Okay, that's going to be true because we're on the same line. Okay, these are always going to be the same because we're on the same line. All right, let's add another note up top. Okay, so remember, when we are finding the slope from a graph, we're looking for the rise over run ratio. So let's go ahead and put that right here. Our rise over run. Okay, and we're always going to read the graph from left to right. So write that in. Read the graph left to right. And if you do this, that means your run number on the bottom will always be positive. Again, if you do this, the run number will always be positive. Because when we go to the right on the coordinate plane, we are increasing the x value. It's a positive. So we'll get our sign from the rise factor, okay? We'll always have a positive number on the bottom, but the rise, we go down here to our little formula here, our ratio. The rise will be a positive number when you go up. It will be a negative, though, when you're going down. Again, this is left to right, left to right. So that's where you can get your sign. It will be in that part of the ratio. We will call slope, we'll use the variable m. So we'll put the m right here. So m is the variable for slope. We'll see it used in different linear equations. And then one more thing, we want to make sure that you choose points that are in the corners of a grid square. We talked about it earlier. A, B, and C are actually given to us in the corners of the grids. So when we go to the next page, they're not going to give you the coordinates. So it's very important to find points that are in the corner of a square. All right, let's go to the next page. All right, you're trying to find the slope of this line, of this graph. Let me zoom in here. This is your practice, number 9. So first thing you gotta do is find 3 points. Find some points on there, at least 2 points, okay? So you're going along the graph here, left to right. I want you to tell me to stop when you see a point. Stop right there. Right there in the corner, it goes right through the corner of a square. That's gonna be a coordinate we're gonna use. We don't want to use anything else because we don't know exactly what this y value is. Could be negative 6.5, 6.4, who knows? We know this is exactly negative 7, negative 6. What's the next coordinate we see?
Stop.
Right there, the y-intercepts. Okay, there's no other coordinates in between. You might think that those are going to be good enough, but these are not. It's not exactly through the corner right there. See how it's barely not touching it? Okay, it has to be not exactly through the corner. Okay, what's the next possible point? Tell me when to stop.
Stop.
Right there. Okay. So there's the coordinates you want to use to start finding your rise over run. Okay. So let's go ahead and do that. From left to right, if I'm at this point, do I have to go up from here? Do I go up or down? Do I go down? Down would be going away. I want to go up to the next point.
If the graph is decreasing.
Yeah, if the line's going down like that, someone said, that would be going down for the next point. We are going up left to right, so we should have a positive slope here. So we see we're going up 1, 2, 3. So up 3. And then how far over to the right? 1, 2, 3, 4, 5, 6, 7. So to the right, 7. Okay. So let's go ahead and build our ratio here on the side. So M, remember, refers to slope. Again, it came from our rise over our run. We went up 3. Now, you don't have to do this part, but it's nice to see. If you write up 3, you know to write a positive 3 on top. Okay. And if you say to the right 7, we know all numbers to the right are positive. That'd be a positive 7. And we look to simplify the ratio. Is there any way we can simplify this ratio? Nope. So that's our slope. Our slope is M is 3 over 7. That means go up 3 and over 7 when you graph. That describes how the line changes. It's going up 3 and over 7. Now, let's say you didn't see that middle point. Let's say you didn't see there was a point right there. You're like, I don't trust that one. I only trust this one way over here and this one way over here. Will you get the same answer?
No.
You will when you simplify. So let's go ahead and test that theory out. So from this point way over here, I have to go up how far? Up 6. Up 6. So 6. Over the run from -7 to all the way to +7 is to the right 14. So +14 on the bottom. That does reduce to be exactly the same. 3/7. All right, we have some room on the bottom here. I want to use this for notes on how to find the slope from a table. All right, so I'm going to zoom in on the bottom half here. You can use the top or the bottom of your page, wherever you have room here. So let me zoom in. So these are going to be notes on finding slope from a table. So slope from table. This is my favorite method. It is useful for also given 2 points. Okay? All right, so we're going to call it is the delta method. So use the delta method. Okay, what that refers to, if you saw on the previous page, delta is the Greek letter that represents change in a variable. So when we talk about delta method, we're looking at setting up a ratio of the change. Delta is that, the triangle there, the change of y, how the y changes, over how the x changes, delta x. Okay? So that just refers to the change of y over change of x. It's the same thing as rise over run. You just saw in the graph how it changed in its y. It went up 3. Okay, that would be the delta y part. And when it went to the right 7, that was the delta x part. Okay? So it's easy to see in a table. Okay, so when we build a table here, let's go ahead and do that. It's x and y. Let's choose, I like 7s. -7, 0, 7, and 14. Y value is -6, -3, 0, and 3. Okay, so we're going to build our ratio of the slope based on how it's changing in the y column and then how it's changing in the x column. So over here in the y's, pick any two you want. I'm going to do the top two. So from -6, draw an arrow down to -3.
Plus 3.
And how's that changing? It's adding 3 to get there. Adding 3 to get there. You can look at a number line. And you look at the number line and go, oh, at -6 to get to -3, I have to go to the right 3 or up a value of 3. So 3 goes on top of our ratio. That's a change of y. And how do I change this -7 to a 0? By adding 7. By adding 7. That goes on the bottom. X goes on the bottom. Y is always on top. So there's my slope, 3/7. No formula. Nothing to memorize. As long as you remember how to find the change of y over the change of x. That's the concept of slope. Okay? Hey, will that work anywhere on the table? Sure will. Sure will. So if I able to erase the two middle parts and go, I don't have only these two coordinates, -6 and maybe +3. How do I get from -6 to +3? I would have to add 9, get to -6 to +3, add 9. So my ratio would be 9 on top. Okay. And then how would I get from -7 to +14? -7 to +14, what'd you say? Plus 21. 9 over 21. What's 9 over 21 reduced to? 3 over 7. So it doesn't matter where you choose, as long as you reduce in the end, you'll still get your correct slope. All right, last thing we're going to do to find slope is slope between 2 points. All right. So this page will be slope from 2 points. 2 x, y coordinates. All right, so this, a lot of people have seen this used for a formula. So maybe you've seen this before. The slope formula. We'll put it down here for 11C. I don't recommend memorizing this. I recommend understanding the concept of slope, the change of y over change of x. So there is a formula to find those changes. Okay, so we'll call this m again. Nope, that's not it. So again, we're looking at the change of y and the change of x values. Now, how can we do that mathematically given two coordinates? Because we're talking about two coordinates given to us. Here's the first one's called x1, y1. The second one will be called x2, y2. Okay. So how can we find the change between two numbers? What operation? Minus difference, the difference. So make sure we do our subtraction of x's where? On the top or bottom? Bottom, change of x on the bottom. So we could mathematically calculate the change between two y values by taking their y values and subtracting. y2 minus y1. Okay, that will show us our change vertically, our change of y. And now our change in x, we take the second x value and subtract the first x value. So remember, we're given 2 points up here. You have to remember which one's which. So it might be good to label those x1s, y1, x2, and y2. Now you can find this another way, kind of backwards, but it does work this way. It's not very common. You might see it, people do this. They might subtract y1 from y2. Now that's not wrong. It's not as wrong as talking during lecture notes. Not writing them, not paying attention. It's not going to help you on the test. Okay, I have evidence now that you are not paying attention. Okay, if I chose to do y1 minus y2, I got to do the exact same way with my x's. I got to be consistent. That means I take the first x value then and subtract the second one. Either way works. The most common one is what you see here. Okay, this will be about last time I'll probably write the formula, because I don't want you to use it. I want you to understand what slope is. All right, but let's go ahead and practice using it on 2 examples up above. All right, so those are 2 points, -4, 11, and 1, -9. So if you're going to use the formula, it's going to be a good strategy to label each part. So if you want to go left to right, we should. This first x value, we'll call that x1, and this is y1. That means over here is going to be x2 and y2. Okay, you can put it above or below to keep organized, because we have to fill in the ratio based on the formula here. So we are always subtracting the y's over the subtracting the x's. So if we're going to do y2 minus y1, we're looking at the second y value, -9, subtracting from the first y value, 11. So -9 minus 11. Now I use arrows to stay organized. See, if I see this arrow from here to there, I'm going to draw another arrow from my x value from here to that x value, because that's going to be on the bottom. From x2 minus x1, 1 minus -4. Keeping the arrows keeps you organized. Make sure you subtract in the same direction consistently. It also notice that the y's go on top. I put an arrow on top, so remember to put this on top. My x subtraction goes on the bottom. Now make sure you see those double negatives on the bottom at least. Up top we have -9 minus 11, so it becomes more negative to be what? -20. On the bottom we see a double negative happening. It becomes plus, so what's 1 plus 4? 5. can you reduce negative 20 over 5?
No.
Yeah, you can. What is it?
That will be 1
4.
and then over negative 4.
Negative 4.
Negative 4 over 1. Okay.
Negative 4.
Which is just negative 4.
Yes.
Okay, because negative 20 divided by 5 is negative 4. Or use a calculator. It will reduce it for you. Okay. Now I left this ratio over here. This will help us graph this slope. Remember, all of our whole numbers can be written as a fraction. Because now if I wanted to graph this thing, which we're going to do in a couple days, that part tells me to go down 4, and this part tells me to go to the right 1. Okay. All right, so we just learned the slope formula. I did this example on the whiteboard, but let me show you the shortcut way of finding slope without having to memorize the formula. Okay, we're going to use the delta method on these 2 points. Okay, the delta method was for the table. We don't have a table here, but we could build a mock table. I could stack these coordinates up. So negative 8, negative 4. I could put that underneath the other one. Now I kind of have a table in the mix here. My x's are here, my y's are there. What's great now is I'm going to use the delta y over delta x. So how is it changing from negative 7 to negative 4? What's it doing? How do you get from negative 7 to negative 4? You're adding 3. My change is 3, so 3 on top. My change of the x in the same direction, from negative 2 down to negative 8, what do? Subtract 6. So 3 over negative 6 reduces to be the same thing we got using the formula on the whiteboard. Okay? If you understand the delta method, it's the easiest way to find slope given 2 points or a table. Okay? Think of what we did here is we stacked the points. Stack the points. Okay? And then you could use the delta method. May the math be with you.